anybody in this class need to pull out anything from last quarter to recover their grade from a F to a higher grade? If so, I'm not asking you to raise your hand. If you, I will hold on to that box. Okay? You need to get anything out that you would like to get your grade higher with. So if you did not pass a test, therefore that means you need to retake that test. So if you would like to, you need to get out your stuff today from the box. If not, I will make you do everything again. Love you all. Okay, so make sure you get that out. I'm giving exercise. Not that you need it. Oh, we're recording already. Triangle. Okay. Everybody pay attention. This is our goal today. Is I'm going to try to show you something. Okay, here we go. Oop, I want a segment actually. Sorry. It's been a while since I've played on this. Okay. Okay, so I'm trying to draw these two triangles, okay? My whole goal, please guys, help me out here. Okay, so now I just need to move point E around just a little bit. Okay. Alright, so now hopefully I'm able to create some angles here. Okay? So boom, boom, boom. So that's 43.6. Let's see if I can get another one here. Okay. My goal is to notice, see guys, see how that, I'm trying to make them similar here. Hold on. We're going to just assume that's the same, okay? You guys see that? Put away your stuff, guys, or you can just go out. I'm really done with electronics, guys. If you'd rather be on your electronic, go play at home. Okay, so basically these two angles are the same. Now I want you guys to see that I'm going to look at this angle right here. Boom, boom, to boom. 68.2. My hope is that this guy's also going to be 68.2, but I don't know. Okay, he's not, so I'm going to make him, and then we're going to check something out here. Hopefully you guys understand this is not exact because I'm trying to get the heck out. I love myself. Hi. Yes, those are important. How about, hey, how about you get a piece of printer paper out of there and make it a nice, like, will you just write everybody's name down with nice phone numbers? Right. I decided to give you a little bit more work. Love you anyway. Okay, so he's 74.3, so I'm going to make him about the same. Hopefully this sucks. I know, give me a second. Thank you. Okay, this is going to have to do. I'm sorry. I'm trying my best to show you guys this, but okay. Just notice here that they're roughly the same angles. Can you guys see that for me? Roughly. I know they're not because this is 43 and this one's 41, but can you guys bear with me here and understand that? Let's assume they're the same, okay? Okay, so if they're the same, let's go ahead and find this angle B and this angle F. Okay, with this being angle B here, oh, funky butt loving. Oh, there we go. Okay, wow. I kind of thought so myself. Okay. Let's just see if I can maneuver here. Thank you. I don't know if I can. Anyway. Hey, that's semi-decent. Okay, we can work with that. Okay, I'm semi-excited now. Yay! Okay, now once again, this is what our lesson is today. Notice, no, the lesson is proving triangles similar. Okay? What have we talked about in the past that a similar triangle is? Has to have all the angles the same. Once again, I'm justifying that all these angles are the same right now, okay? Is everybody with me on that? Okay, all these angles are roughly the same. Now, if the angles are all the same, therefore the sides have to be proportional, don't they? Okay, so let's go ahead and look at here really quick. And I am going not to be able to write up. Okay, so notice, what is the length CB? Well, it tells us right here. Oh, dang it. Sorry, I should have played around beforehand. Oh. You did say that. Okay, that's segment D. Everybody write 5.39 down, please, roughly for me, so you guys can help me out. Who corresponds with segment D? This side right here, huh? What is he? H. He's 4.01. Can you write that over? So go 5.39 over 4.01. Okay? Who corresponds with this top, which is C? 4, right? He's 4. Please write 4. He corresponds with this side right here, doesn't he? Is everybody with me on there? Addie, you okay? And that guy is 2.95. Please write that ratio. Okay, here's this one. So we'll just say BC is 5.39. And this guy right here is H, which is 4.01. So we wrote 5.309.39 divided by 4.01, right? Is everybody there with me? Yes, no? Okay. Now, we're going to write 4 over 2.95, please. So write 4 over 2.95. And then our last one, 5.39 over 4. Okay, is everybody there with me? Close enough, right? Just a little bit over, but as we wrote it, let's divide all of those. So we had 5.39 divided by 4.01. That's roughly the same thing as 5.39 divided by 4, right?
Can I get McKenna, them non-friends to the front office, please?
Yes. Okay, when I divided that, I get the same thing. So the only question we really have is 4.95. Is that divisible? It wasn't, excuse me, 4 divided by 2.95, isn't it? Okay, somebody put this in their calculator and put this in their calculator and tell me the decimals form, please. So 5.39 divided by 4 and 4 divided by 2.95. This one right here? 1.3475. Okay, what about this one? Okay, so we're really, I mean, guys, I know I'm off, and you guys understand that I know I'm off, okay? I couldn't get into that. But are they pretty much the same ratio? And how did I start with this first? I had nothing to do with the sides, did I? No, I didn't make anything with the sides. My goal was that I had this angle and this angle here, right? And I was trying to make those two guys equal to these two angles over here. Correct? Does that make sense? Notice if you know two angles are the same as the other guy's two angles, what comes about the third angle? They're equal to each other as well, aren't they? Does that make sense? If two angles are the same, doesn't that third angle have to be the same as well? Right? Okay. Now, are those the same shapes? No, they're not, because the sides are different, right? Well, they're still triangles, but I'm saying, are they the exact same shape? They're similar. Why are they similar? Because the angles are all the same, and the sides are proportional. Well, what I'm trying to teach you today, guys, is not every time do we know that all the angles are the same. Like on the last time we've been doing this, we assumed that all the angles were the same. So we were trying to prove that if the sides were proportional, therefore then, because the angles were all the same, then this triangle is proportional, right? Or that figure is proportional. Does that make sense what I'm trying to get at here? Okay. Well, today, sometimes you don't have all the angles. We don't know all the angles were the same. So how can you still prove things are triangle? How can we prove triangles are similar? Well, there's a couple ways. Let me show you how. Okay, in those couple ways is this. There's 3 different ways to prove triangles similar. So this is called similar triangle. Okay, and there's 3 different ways to prove things are similar. You have angle, angle, similarity. Last year, you should have learned, if you'll recall, side, 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 angle, side, angle, angle, side, angle, side, angle. Do you guys remember those things? Angle, side, side is not one. Everybody wants it to be one. But it is not one that works. Okay? So, we actually have angle, angle, similarity. What this means, guys, is if I have a triangle, and I have another triangle, are those the same triangles, first off? No, so they're not congruent, but they could be similar. Okay? So if I said this guy is 30, and this guy is 70, this guy's 30, and this guy is 70, what do we automatically know about these two angles? How do you know that? And this is so far 100, so therefore this must be 80, and this must be 80. So therefore, if we know two angles are congruent and another triangle's two angles, the third one automatically comes along. That's what I just basically said, right? Well, guys, with this being said, if they're the same angles, then therefore the sides automatically have to be proportional. Why? Or they wouldn't create the angle. They couldn't. Okay, let me explain why. Hopefully I can draw this one better on a picture, okay? I'm going to work with it. Bear with me. We're going to try it. Here we go. Okay. Get out of here, you scallywag. Okay, here we go. I'm going to draw some points here. I hope. Okay, now, once again, okay, I could try, I'm going to try this one more time. Hold on, hold on. I'm going to do the angle. Boom, boom. Oh, funky. No! Why do I suck? Because I'm trying to, I could do it, but I'm trying to show you why. It's not working.
Why don't you just...
Fine, I will just go it here. Okay. You guys, can you use your imagination with me just a little bit then? I was trying to show you with the mechanical thing, but, okay, put them back there just for one thing. I want to just make sure. I'm not saying I don't trust you, but they're very important numbers. Do I trust you? I would 3/4. 3/4. Okay, so, notice, okay, stop right here with me guys, please. So, if I had this guy and this guy, and that creates the 30 degree angle. Let's start making that same 30 degree angle. Okay, you guys see what I'm trying to get at here? Now, I'm going to create a 40 degree angle from here. Well, that's not 40, let's say that guy is 8. Okay? Notice this side was a little bit longer, huh? Or I can make them a little bit shorter. Because I can make 80 degrees from anywhere, couldn't I? That's basically what I'm trying to get at. I'm going to make them shorter. Okay? But I still want to create that same 80 degrees. Okay? Well, sooner or later, they're going to intersect, correct? If I pull them apart. Does that make sense to you guys? Sooner or later, these guys will intersect. What angle will they create? 70. Okay, we just talked about that if that's the case, two of the angles being the same, they should be the same, right? Yes, sir. Okay, let's just pretend this was, oh, you guys think that's 5 inches? What do you think? 5 inches? Okay, 5 inches. That's 5. Okay. Just say okay. What do you guys think this is? 8. 8? Okay, we'll say 8. Okay, so if I measured this guy, he looks about 8 as well. Roughly, he looks about the same size as he does, right? Does this guy look like roughly about 12? Yeah, or maybe, let me think here.
I think 12.
Yeah. Let's make him 9 instead. 9 and 12. Okay, that's kind of okay. And then this guy, he looks a little bit longer. Well, he looks a little bit longer, so let's just assume he's 7. Final. Okay. Well, and then let's find him. How? That's not what we should do. How can I set this up? Well, for it to be similar, what do I know? I know, once again, guys, I know I'm not exact here, but you're bearing with me, right? Hopefully, using your imaginations with me. Okay, the 6 for the 5. Oh, Jesus. Did I say that was a 6 or a 5? 5. It's a damn 6. It's a 6. Because I just made my proportions off of that being a 6. So 8 over 5, 6, should equal 12 over 9, huh? Does it? Yes. How can we tell? We could reduce down, that's one way. What does 8 and 6 have in common? 2, and that's 4 and 3. What does 12 and 9 have in common? A, D, and B, right? You guys see that one? And then I have triangle EDC. You guys see it? So I have the big one on the outside here, and then this guy. Two real triangles. Are they similar triangles? Possibly. Well, let me prove it to you. Okay, now this is where you might have to come into last year. Well, I'd like to show you some things that you remember hopefully from last year. If I have two lines that intersect, okay, and now let's just pretend this guy's 100. Can anybody tell me what this guy is? Does anybody remember from last year? 80. Do you remember why? A line has to add up to be 180 degrees. Well, if this guy's 80, how much is this guy? 100. Well, if he's 100, what's this guy? 80. Okay, do you see how the sides on the opposites are equal to each other? The reason being, you guys remember the word supplementary? Two angles that add to be 180? Well, look, this angle and this angle both are sharing a supplementary angle, aren't they? They're both supplementary to the same thing. Right? And obviously, therefore, then these two have to be equal if they're sharing a supplementary angle. Okay, just like these two are the same and they're sharing a supplementary angle, that's why they are the same. Right? Understand, whenever you have two lines, if I said 1, 2, 3, and 4, I know angle 2 is congruent to angle 4. I know that. I know angle 1 is congruent to angle 3, and they are called vertical. Vertical angles. Okay, does anybody remember that from last year? I was told that you were taught this last year. I'm sorry if you didn't, but here's your learning if you didn't. Okay? Those are called vertical angles. They are congruent, and I just basically proved that to you by putting a value for the degrees and figuring out because of supplementary angles, right? Okay, how many of you guys remember last year if I have two parallel lines cut by a transversal? We have what we call 1, 2, 3, 4, 5, 6, 7, 8. Can anybody tell me my pairs of vertical angles? Give me 1 second. Vertical angle. So you said angle 1 to who? Can't say that yet. We'll get there. Just vertical angles. 1 is congruent to angle 4. Remember those guys on the opposite side intersecting, right? Who's another pair? 5 and 7. Okay, I'll accept that. 6 and 8 are. We have one more up there. 2 and 3. Good. Is everybody there with me? Okay, those guys are the vertical angles. Now, I also know angle 2 is congruent to angle 6. Can anybody explain why? If you got parallel lines, they're both rising and running the same amount, right? So if you have a line cutting through them, that line cuts through the very exact same way, doesn't it? So therefore, exactly. Therefore, this angle is the same as this angle, and they're called corresponding angles. You guys remember that from last year? Yep. Corresponding. Okay, corresponding angles. Let's go with the pairs of corresponding. Who corresponds to angle 2? 6. Angle 6. Who corresponds to angle 1? 5. 5. Does everybody understand what I'm meaning by this? This helps us in our thing today, okay? You okay? It doesn't matter really. No, because we're just calling them numbers, right? I know it's bothering you because I went 1, 2, 3, 4, right? But it doesn't really matter though. I could have called this H if I wanted to.
What you call where like the 1 and the 5?
1 and the 5 are called corresponding.
Corresponding.
Okay, so angle 3 goes with angle 8, and then angle 4 goes with angle 7. As long as we have that picture, we know that they're going with it. Does that make sense to you? Because I could have made this, I could have went 1, 2, 3, 4.
Yeah, I just thought it was
I'm sorry. Okay.
2 and 6 would be green.
Yes, 2 and 6, 1 and 5, 3 and 8, 4 and 7. Those are all corresponding angles. Now, I got a question for you, okay? Yep. If I have $5, you have the same amount of money as I do. And you again have the same amount of money as you guys have what amount?
Because you're over there.
So what? So, you get this is what I'm saying. How much money does Hunter have?
12.
a middleman, right, that are equal to, where we shared somebody that we're equal to, and then basically we are equal to because of her, right? She was equal to me, he was equal to her. We can get rid of her basically and say we're equal to each other. Okay, that's called the transitive property. If A equals B and B equals C, I know A equals C, right? Well, same thing here. If angle 1 is congruent to angle 4, and angle 4 is congruent to angle 7, what's one? If angle 1 is congruent to angle 4, we already know that. And 4 is congruent to 7, I know angle 1 is congruent to angle 7. And notice, see how that's here and here? Let's go again. It's just like if I have the same amount of money as she does, and she has the same money as me, we can get rid of her. Angle 1 is congruent to angle 4, but angle 4 is congruent to angle 7. I know angle 1 is congruent to angle 7. Those are called, how about this, guys? How about this? See if any vowels come. Alternate exterior. Anybody remember those? Those are the same, right? Do you guys understand why they're the same? Okay, so then we also know angle 2 is congruent to who? Angle 8. You guys see how congruent? Right here. Angle 2. So it's 60. Because it's reversal. Awesome. That's your thing. Notice if angle 2 is congruent to angle 3, and angle 3 is congruent to 8, and angle 2 is congruent to angle 8. You guys see that? If I know we have all of those are all my exterior angles. You guys see how they alternate? What does alternate mean, do you think? Different sides, right? We can think of alternate views, different sides, right? Alternate, and then what is exterior? See how they're the outside of the parallel line, right? So they're outside the opposite. Okay, what about the interior angle? Alternate interior. What about 3 and 6? Well, I know 2 equals 6, don't I? Because it's corresponding, but 2 equals 3. So therefore 3 is equal to 6 because of alternate interior angle. Does that make sense? See, I'm using the transitive property. Alternate interior is angle 3 is congruent to angle 6, angle 5 is congruent to angle 4. Okay? Well, with that being said, I can now come back to my problem here and say, are these shapes similar? Well, let's draw these shapes different. I'm going to draw them a little bit bigger. Because sometimes when they exist like this, it's hard to say things, right? Well, you know, this is A, B, and E, and then I got my little guys over here. D, E, and D. Okay? What do we know about angle D? Why are they the same? It's basically if I clone myself, obviously I'm going to be the exact same thing, right? If that mini-me would not be the exact same, right? We're trying to be exact on angles, aren't we? On proportions, like on the sides they can be proportioned, but on angles you want them to be exactly the same, right? Does that make sense to everybody? So, do I know angle D is congruent to angle E? I do know that, and actually what we call that is the reflexive property. You'll write that down. Angle D is congruent to angle D because it's the reflexive property. Notice when we look in the mirror, it's exactly the same because it's reflective, right? Make sense? Reflexive property is like when angle D equals angle D. Okay. Now, did it say that any of our side lengths are proportional to any of our side lengths? I can't prove it that way. Remember, what's our 3 ways I can prove it? Angle, angle similarity, side, side, side similarity, or side, angle, side similarity. Those are the 3 ways we can prove it without knowing everything. Sarah, you can just go outside of my class. I'm really done. I can't remember your name. Mason. Have a good day. Have a good day. So, with that being said, okay, I know angle D is congruent to angle D. Now, you cannot just put a tick mark without knowing why. Does that make sense? I know angle D is congruent to angle D. What's my justification? The reflexive property. Does that make sense? Okay. I also know that angle A different sides, and they're not exterior. Corresponding. They are corresponding angles. So I know angle A and angle E are congruent because of corresponding angles. So once again, I said angle B is to angle B because of reflexive. And then I know angle A is congruent to angle E because of corresponding. Does that make sense? Did I just say that they're congruent, or did I have a justification? I had a justification, didn't I? Does that make sense to everybody? Do I have enough now to prove that they're similar? Which theorem? AA. If I have two angles that are the same, that's what that means. Then they're similar. Okay? If you have three sides are proportional, then that means that those triangles are similar. If I have a side, an angle, and a side corresponding to an angle, a side, and a side, and the sides are proportional and the angle is the same, then the whole triangle are similar. Those are our three theorems. So therefore I can say triangle A, B, D is similar to who? Who corresponded with A? E did, right? E, C, D. Because of angle similarity. I have proven everything. I just didn't say because. I said, here's the reason. I know this is because I know it's reflective. I didn't just say they're congruent. I said, these guys are congruent because this is reflexive. These guys are congruent because these guys are corresponding. Because I have two angles that are the same, I know I can prove it by angle similarity. So therefore these triangles are similar. Okay, so let's go for another one. Basically, number 4 of our bell curve. If I didn't give you those angles, I couldn't say that they're similar right now, right? Unless I prove what? That all the sides have the same proportion or ratio. So who corresponds to 7 again? 21. Who's corresponding to 5? 15. Who corresponds to 10? 30. Okay, notice I did cross multiply, see if it is. That's 105, 105. That's 150, that's 150. Therefore, or you can just kind of say 1/3, 1/3, 1/3, right? Do they all have the same proportion? Because they all have the same proportions, then therefore, if I had points on there, I could put triangle A, B, C is similar to triangle B, E, F. Because of side. You guys see how I'm trying to prove it? But I'm showing and justifying my answers. Okay, and the last one, okay, is if I said this side's 2, and this side's 4, that side's 10, so that side's 20, they both form a 50-degree angle. If they form the same 50-degree angle, and this guy was 2, 4, 5, and 10, right? Then automatically, if those guys form the same, then this distance and this distance have to be proportional as well. Does that make sense? Yeah. So therefore, then after that, then we basically have a side. But right now, we don't know what the lengths are, so we can't actually say side. But we could prove, okay, the angles are the same. We'll call him D and E right now. So angle E is congruent to angle D because of given. Wasn't that already given to us? Right? And then I can say, okay, well 2/4 equals 15-year-old? Would you like one for your friend?
I like to find a big ear.